we'll now do sound B number 5. And in sound B number 5, it says a train locomotive approaches a crossing at 95 kilometers per hour. The train's horn has a frequency of 288 hertz. What is the frequency of sound heard by a person at the crossing? So our variables are going to be velocity of the source, frequency of the source, velocity of the observer, and frequency at the observer. Now for this one, the person at the crossing is the observer, and the train is the source. So it says the train approaches the crossing at 95 kilometers per hour. So velocity of the source, 95.0 kilometers per hour. Now right off the bat, this isn't what we want. We want this in meters per second. So what we have to do is convert. So once again, when you convert, you're going to want meters on the top and kilometers on the bottom. So now kilometers cancel out, giving you meters in the top. And to convert from hours, if I put 1 hour on top, I have to put 60 times 60 for 3,600 seconds. That's how many seconds are in an hour in the bottom. And this will give me 26.39 meters per second. So this train blows its horn, and the frequency of the horn is 288 hertz. And the observer is standing at the crossing, so they have a velocity of 0 meters per second. And we want to know what is the frequency heard by the observer. So our general equation for this is going to be the frequency of the observer, this is a Doppler shift problem, is going to be equal to the frequency at the source over V plus minus. And up on top, we have the velocity of the observer over V minus plus the velocity at the source. Now, one of the things we need to know is what's at the top of the sheet. And it says the speed and sound of air for that particular day is going to be 334 meters per second without any motion. But because the source is in motion, the observer will hear a slightly different frequency. So on this one, let's go ahead and plug in some numbers here and figure out what we're doing. Remember, the top means towards for the signs. So if we look at the very top part, the numerator of the equation, we'll see that the sign won't matter too much because the velocity of the observer is 0. Now in the denominator of the equation, what we have here, remember top means towards, and a train is approaching towards the junction. So we're going to pick the top sign here, which is the negative sign. Top means towards. So we get frequency at the observer is going to be equal to frequency of the source times V in the numerator over V minus the velocity of the source. So plugging in our numbers, frequency observer is going to be equal to 288 hertz, which is the frequency of the source, times V, which is the standard speed of sound in air for this day, is given on the worksheet, is 334 meters per second over 334 meters per second minus that velocity of the source, which is going to be 26.39 meters per second. Plug that into your calculators, and you get the frequency at the observer is going to be equal to 313 hertz. Which, just doing a little mental check here, if the train is actually approaching the observer, or the source is approaching the observer, the frequency should